Alright guys, welcome back. On this question, we have a rod AB that is hinged at A and attached to a cable BD at point B. We know that the distance D in here is 150 millimeter, and in the A part we need to find the tension in the cable BD, and B part we need to find the reaction at A. So as always, we're gonna start with free body diagram. So what we have is the tension at point B, let's call it T BD. We have the 290 Newton forces, and at A we have, since it's a pin, we will have AX and AY, and we don't need to consider any moment for point A because it can rotate freely. That's pretty much all the forces that we have in this question. I'm just going to show the distances with green. So we know here is D, which is 150 millimeter. We know this part is 100 millimeter. Same for this one, 100. So the whole of this distance is 300. And since A to D is 150, here to here will be 150 millimeter. And that's pretty much what we have. Let's just go with our equations since we are in equilibrium. So we are in equilibrium. And therefore sum of all forces and moment will be 0. So let's start with the moment equation first, and we're gonna start with the point A since we can cancel out all the unknowns at point A. And if you do that, we'll have the moment of the cable TBD about point A. So if we continue that line of action, we'll get somewhere in here, and let's call this angle here alpha, and we need to find that angle. Also, we know from here to here, so from the question we know that this distance is also 100 millimeter, same as the other ones. So having said that, we can find the angle alpha since we have the dimension. So simply, if we want to find the, let's call this alpha. So if we want to find the tangent of alpha, we'll have 10 over or 100 over 150. And from here, we can find alpha, tangent aversive 100 divided by 150, which would give us 33.69 degrees. So that's our angle. So we need to find the moment about, and now that we have the alpha, we know that this is our TPD, and only y component, let's consider our x and y in here. The only y component can make moment about point A, and that would be the sine of that angle alpha. And since it's making a counterclockwise moment, so I'm gonna show it in red. So this will be the y component of the cable, which makes this moment again counterclockwise about point A. Therefore, it will be positive. So we'll have positive TBD sine of 3369, and the distance will be 150. We also have the moment of the other two 90 Newton forces, and they're all clockwise, so will be negative. So we have 90 times 100 millimeter, which is 1.5. Let's just go everything with meter. So we're going to divide everything by 1,000 to get the units in meter. And we have the moment of the other one, which is 100 plus 100, so 200 divided by 1,000, or 0.2 equals 0. Let's just show this one the same way too. So we'll have 100 divided by 1,000. So from here, the only unknown would be the tension in the cable. So TBD will be 324.5 Newton. So that's the A part of the question, that we need to find the cable in the tension in the cable. So we have the reactions, but we still haven't used our forces equation. So we'll have Fx and Fy as well. We already showed the direction of X in here, but we can show it like next to our equation too. So let's see what we have at X direction. So we have AX, and we'll have the X component of the TBD. So we'll have AX, and the component of the tension will be negative since we are to the left, and it will be TBD, and it will be the cosine of the alpha, which was 33.69, equals 0. And from here we can find AX, which will be 270 Newton, and it will be to the right. The last equation would be our Fy, so we'll have AY. We'll have the 90 Newton forces, which are all negative, and we have the TBD Y component, which we found in the moment section. So TBD sine of alpha, or 33.69 degrees. If we find this, we'll get 0 for AY. If you want to find the magnitude of A, we'll have AX squared plus AY squared, and that would be basically 270 Newton